Hello everyone, welcome to this video. In this video, we are going to learn about quadratic equations. The topic of today's video is quadratic equations. It does not really have many prerequisites, so you should be familiar with basic algebra, like how to add and subtract like terms and what an equation is, what are its roots, and stuff like that. Okay, so let's begin. So, what is a quadratic equation? Obviously, if you have something like this is called a standard quadratic equation. Ax square plus bx plus c equals to 0. Here a, b, c are called constants, which means their values do not change. And x is a variable. You might have seen this kind of things a lot before. These are called equations where we solve for the value of x, right? X is a variable. The linear version of this is simply the linear version is simply ax plus b equals to 0, correct? Which has the solution x equals to minus b by a. Now, this is called the quadratic equation. The reason being the highest power of the variable x is basically 2 here. And as long as that term is here, it is a quadratic equation and that it is the highest power. So if there was the x cubed term, it would no longer remain a quadratic equation. It would be a cubic equation. But to retain this x squared term, the coefficient of x squared must be non-zero. So this is a very important property of a quadratic equation. The leading coefficient, the coefficient of the highest power term, in other ways, should not be 0, right? Okay. Now, let's go to the main criteria. So I will rewrite the equation here. Ax square plus bx plus c equals to 0. Now, the quadratic equation is well studied and it can be solved completely for any values of a, b, and c. So first, let's see how to do that. So if you're given such an equation where a, b, c are some numbers, right now I'm representing them as a, b, c, but they're simply some numbers, right? How do you basically proceed? Okay, first of all, you multiply 4 of it to both sides of the equation. This is a technique which I'm going to do is called completing the square. The technique is called completing the square. And using this technique, we are going to find out that any quadratic equation basically can be solved in the same way if you do not really want to apply the direct formula, which is the Sridhar Acharya. Anyway, so if you multiply 4a, it becomes 4a square x square. This one becomes 4abx, and the last term becomes 4ac equals to 0. Correct? Now, the first term here, this is basically 2ax whole squared. And if you can write the second term like this, 2 times 2ax, which is 4ax, only a b is left, there is a b. But now if you add a plus b square to it, it becomes a perfect square, right? But there is no b square, which is why we also subtract it and write the remaining terms as it is. Now, send this part to the other side of the equation and combine the first three to the a plus b whole square formula, and you get this 2ax plus b whole squared is equals to b squared minus 4ac. As I said, transfer this to the right hand side of the equation, right? Now, if you have this form now where square of a number is equal to another number, then obviously this number inside can be can have like two values, right? Because it's a square. So what I'm basically saying is the normal equation x square equals to a has two values, and the values are basically plus minus root a. So there are two values because if you see carefully, root a squared also gives you a, and minus root a whole square also gives you a. Right? That is why there are two values that will square up to a. So this now gives us 2ax plus b is plus minus root over of b square minus 4ac. For our convenience and for the language of mathematics, which what everyone calls this is the discriminant. Let capital D equals to b square minus 4ac. This is called what? The discriminant. discriminant. And this basically decides the nature of the roots and how the quadratic equation is going to behave. Okay. Okay, so let's proceed and replace that with D. So what we have is basically now a simple linear equation, right? Like this. But we have a plus minus. This will give us 2ax equals to minus b plus minus d. And therefore, the value of x simply becomes minus b plus minus d by 2a. If you plug in the value of d, you can simply find out that the answer is this b square minus 4ac by 2a. This is called the Sridhar Acharya formula. Right. So we started with the equation ax square plus bx plus c equals to 0, and we ultimately arrived at this part, right? So this is called the Sridhar formula, where given an equation, you can directly solve it like this. Okay, let's take an example. Let's say we have x square minus 5x plus 4 equals to 0. Let's say this is the quadratic equation we are given at hand, and we are asked to solve it using the Sridhar formula. The first step is identify the coefficients. So this should be reminiscent of our standard form, which is this, right? Ax square plus bx plus c equals to 0. This is the form we want. And when you get this form, only then you can conclude that, okay, this is A, this is B, this is C. So you see that A and B and C can be compared now. So we conclude that A is 1, B is minus 5, and C is 4. And that is why, applying Sridharacharya, we can say x is minus b plus minus root over b square minus 4ac whole divided by 2a, right? So what is b? B is minus 5, so minus b should be 5 plus minus b square means minus 5 whole square, which is plus 25, minus 4 multiplied by a is 1 and c is 4 divided by 2 times a is 1. Okay. Let's simplify this further. 5 plus minus, this is 25 minus this is 16, right? And 25 minus 16 is root 9 divided by 2. And root 9 is simply 3. So 5 plus minus 3 by 2. And the two values, you can write them as x1 and x2. We will come later to that, what they are called, why there are two values, and how to deal with these two roots, what properties do they have, and stuff like that. So first one, you take only the positive sign, which simply gives you 8 upon 2, which is 4. And for the second root, you take the negative sign, you get 5 minus 3 upon 2, 2 by 2, which is 1. Both of these values satisfy the initial equation. So that is, if you put in x equals to 4 here on the left hand side, this will give you a 0. So is the case if you put x equals to 1, it will still give you a 0. The fundamental theorem of algebra, the fundamental theorem of algebra basically states that if a equation, let's say you have a polynomial equation of nth degree. So right now we had a quadratic equation, which is a equation of degree 2, right? So if you had a polynomial equation of nth degree, let's say the equation looks something like this. An x to the power n, where an and n minus 1 and stuff like that, these are coefficients, real numbers, plus an minus 2, x to the power n minus 2, and it goes on and on and on. And you have a1x plus a naught equals to 0. Okay. And obviously an not equals to 0, which is why it's a nth degree equation. If this equation is there, there must be exactly n solutions. There must be exactly n solutions. There must not be more, there must not be less. There must be exactly n. And this n solutions are called the n roots of this equation. Each of those solutions are called a root, right? So let alpha 1, alpha 2, alpha 3, and there should be n roots, right? Alpha n be those roots, be those roots. Then the fundamental theorem of algebra also states that this equation a n x to the power n plus a n minus 1 x to the power n minus 1 and all the way up to a1x plus a naught. This can be simply written in a factorized form. So this is a expanded out expression of nth degree and bunch of different terms, right? But they can be written in factorized form. You first write an, the leading coefficient, and then in brackets you write the terms x minus, not this, x minus alpha 1, x minus alpha 2, and all the way up to x minus alpha n. This is the fundamental theorem of algebra. As you can see, when this term equals to 0, that would mean that this term would equal to 0, and this term equals to 0 means x has n possible values because an is non-zero, correct? That is why there are n values, and it only makes sense. That is why it has n roots, exactly. The expansion of this basically gives you this. And that is our point of, that is our talking point basically for this quadratic equation as well. That if we apply the fundamental theorem of algebra, so given ax square plus bx plus c equals to 0, let alpha beta be its roots. Then what we can do is this. We can write ax square plus bx plus c equals to a times x minus alpha into x minus beta, correct? And now this is an identity according to fundamental theorem of algebra, and that is why whatever we do on both sides are always equal for all possible values of x. This is an identity basically. It's like saying 2 equals to 2. But what we can get is the relationship of the roots alpha and beta with each other. That is very important for a lot of purposes and obviously for sums that we'll be encountering later on. So a, and if you multiply this, you get x square minus alpha x minus beta x, and also you would get plus alpha beta, right? Okay, so let us expand out everything. Ax square plus bx plus c, and I will write the right hand side as same, ax square, and this term I will just write it in terms of x multiplied by, as you can see, this simply becomes minus a alpha minus b alpha, and the last term becomes a multiplied by alpha beta, which is the constant term. So comparing coefficients, comparing coefficients, we get, so this is obviously equal. The coefficients of x square are already equal. The coefficients of x must also be equal. So b must be equals to minus a alpha minus this should be b beta, right? Minus a alpha, and this should be minus a beta. Okay, and c must also be equals to the constant term, which is a into alpha beta. From this, what we can get is this. From the first equation, you can see that if you divide by minus a on both sides, what you get is this: alpha plus beta is equals to minus b upon a. And from the second equation, you get alpha into beta is equals to c by a. These are the two relationship of the roots that we can get immediately from a quadratic equation. The sum of the roots is simply minus b upon a, and the product of the roots is c upon a. And this information is a whole lot useful because what happens is, let's say you're given a quadratic equation like this. I'll give an example here. Let's say you're given 2x square minus 5x plus 7 equals to 0. And you have said that alpha and beta are the roots. So if this is the case, then what we can do here is If the question asks us to find the value of alpha square plus beta square by alpha beta, what is the value of this? Now, obviously, you know the values of alpha and beta from the Sridhar equation as well. You know, when we solved it completely, one root, this root must have been alpha, and one root must have been beta. And you can obviously assign alpha to this, beta to this, because it does not matter. The question regarding roots will always be symmetrical like this. So if you change alpha and beta, the question remains same. So how do you do this? But using our new knowledge that we acquired, we can say that alpha plus beta is minus of minus b, which is minus 5 upon a. This simply becomes 5 upon 2. And the product of the roots is 7 upon 2, right? Using this information, what we can do is this alpha square plus beta square by alpha beta. Since alpha beta is 7 by 2, this becomes 2 by 7 of alpha square plus beta square, which we can further write as alpha plus beta whole square minus 2 alpha beta. This becomes 2 by 7. Alpha plus beta whole square should be 25 by 4 minus 2 into 7 by 2 is 7, right? And thus this becomes 2 by 7 multiplied by 25 minus 28 by 4, and this is minus 3 by 4. So 2 by 7 into minus 3 by 4. You cut off the 2's here, and your final answer simply becomes minus 3 upon 14. Once you get acquainted to this kind of problems, you will be doing this very quickly, even in your head. You do not really need to write it all out. So these are the equations that we are basically looking for the problems. These are the kind of problems that you usually get in quadratic equations. There is one more point though that needs to be mentioned. That is the nature of roots. The nature of roots. So okay, in this case, the discriminant that we defined earlier comes into play. So ax square plus bx plus c equals to 0. Let this be the equation. And for this equation, what we are ABC are reals, obviously. ABC are reals. And let alpha and beta be the roots. Okay. So depending on the cases of D. So first case, D is greater than 0. This case tells us that alpha comma beta are real and distinct. So they are real as well as they're distinct. They're not equal. Okay. D equals to 0. This case would tell us alpha comma beta are real and equal. They're also equal. So the condition for equal roots is basically set the discriminant equal to 0. And the last case, D less than 0, tells us alpha comma beta are imaginary, which means the equation has complex roots. It does not have real roots, it has imaginary roots. And always remember, imaginary roots always come in pairs. So if a plus ib is a root of a equation, then so is the conjugate of a plus ib, this, which you know to be a minus ib, right? This is true for any function. So if someone were to say if f of ix is a root of a equation, then so is f of minus ix, because the conjugate of f of ix is simply f of minus ix, right? Okay, so this would be the theory that we need to do. In the next video, we can do a lot of problems from JEE Mains and JEE Advanced and stuff like that. But let me know if you did not understand anything, and if you need to make a new video about something that I missed here. But this much be pretty much it, I think, because there is nothing really that much to cover except for this in the basic section. As we go up, we have lots of things to cover, obviously, like Zetas relations, and the sum of roots, symmetric functions, problems from the Olympiad, problems from previous versions of JEEs and stuff like that. Anyway, so thanks for watching. Please do subscribe, and